What if the reality you're living in right now is just one of countless others, each one a slight variation on the theme of existence? Imagine for a moment that you could step through an invisible doorway and find yourself in a world where every choice you didn't make actually happened, where history took different turns, and where an alternate version of you is living a completely different life. This isn't just science fiction, this is the mind-bending possibility of parallel universes, a concept that has fascinated physicists, philosophers, and dreamers for decades. But here's the real question that stops us in our tracks. If travel between these realities is possible, how did the very first journey occur? What incredible sequence of events, what monumental breakthrough, allowed someone or something to cross that fundamental boundary between worlds? Today, we're embarking on an extraordinary exploration into 30 fascinating theories about the universe's first parallel universe travel. We'll venture beyond the realm of wild speculation and into the space where cutting-edge physics meets boundless imagination. This isn't about giving you simple answers, it's about inviting you into a conversation that stretches the very limits of what we think is possible. From quantum tunneling to cosmic strings, from black hole paradoxes to dimensions we can't even perceive, we'll uncover the most compelling ideas about how that inaugural journey between realities might have unfolded. And the most thrilling part, some of these theories might be closer to reality than we ever imagined. What makes this exploration so deeply human is that it touches on our oldest and most persistent longing, the desire to explore the unknown, to push beyond boundaries, and to discover what lies just out of reach. This journey into parallel universe travel isn't just about physics. It's about the very nature of reality itself and our place within the cosmos. So whether you're a seasoned science enthusiast or simply curious about the mysteries of existence, you're about to discover that the truth is far stranger and more wonderful than anything we could invent. The story of how we might cross between worlds begins with a single step into the unknown, and that step starts right here, right now. Our first theory takes us deep into the bizarre and counterintuitive world of quantum mechanics, to a phenomenon so strange it seems to defy common sense: quantum tunneling. In the subatomic realm, particles don't behave like tiny billiard balls, they behave more like waves of probability. This means an electron, for instance, isn't in one specific place at one time. It has a probability of being anywhere, and there's a small but real chance it can suddenly appear on the other side of an energy barrier that it shouldn't have the energy to cross. It's as if you threw a ball at a mountain and instead of bouncing back, it suddenly materialized on the other side. This isn't theoretical. It's a well-documented process essential to nuclear fusion in stars and even the functioning of modern electronics. Now, imagine an unimaginably advanced civilization that didn't just observe this phenomenon but learned to control it. The central idea here is that they discovered a way to scale up quantum tunneling from the subatomic to the macroscopic, to make an entire object or even a being tunnel through the ultimate barrier, the fabric of space-time itself, into another universe. The energy required for such a feat is almost beyond comprehension. We're not talking about the output of a star. We're likely discussing harnessing the energy of a black hole's accretion disk or manipulating the vacuum energy of spacetime itself. The technological implementation could involve creating a stable, overlapping quantum state between 2 points in the multiverse, effectively forcing a macroscopic object to exist in 2 realities simultaneously until the connection is severed, leaving a part of it in the new universe. This wouldn't be a wormhole or a rip in space. It would be a seamless, instantaneous transition, a gentle nudge into an adjacent reality with no dramatic passage through a tunnel. The first traveler might not even have felt a thing, simply taking a step forward in one world and arriving in another. The physics behind this hinges on the many worlds interpretation of quantum mechanics, where every possible outcome of every event actually occurs, spawning an infinite tapestry of parallel universes. A quantum tunneling breakthrough wouldn't create a new universe to travel to. It would simply provide the key to unlock the door to one that has always been right next to ours, separated by a barrier of probability that was finally, miraculously overcome. While the idea of quantum tunneling focuses on slipping through reality's seams, our second theory takes a far more monumental approach, suggesting that the first journey might have been made not by slipping through but by building a bridge. This brings us to one of the most exotic and powerful concepts in all of theoretical physics: cosmic strings. Think of the universe not as a smooth, blank sheet, but as a complex fabric that underwent a series of dramatic phase transitions as it cooled from the Big Bang. Just as freezing water can form cracks in ice, the rapidly cooling and expanding early universe could have formed inconceivably dense, one-dimensional flaws in the very structure of spacetime itself. These are cosmic strings, infinitely long filaments thinner than a proton, but with the mass of an entire star packed into every mile of their length. Their theoretical properties are almost beyond belief. A cosmic string would possess immense gravitational pull, not by having a large volume, but by having an unimaginable density warping spacetime around it. They are so massive that they could act as gravitational lenses, bending light from distant galaxies, and if one were to pass through our solar system, its gravitational disturbance would be instantly detectable. But their most incredible property for our purposes is their connection to the multiverse. Some models suggest these strings aren't just in our universe. They are scars that stitch between universes, topological defects that formed at the boundaries where different realities crystallized out of the primordial energy. Harnessing such a structure would be the ultimate engineering project. The civilization that achieved this wouldn't be building a spaceship, they would be reweaving the cosmos. The technological marvels required are staggering. First, they would need to somehow locate a cosmic string, a task that would involve mapping the gravitational distortions across vast stretches of the cosmos. Then they would need to stabilize it. A natural cosmic string would be under immense tension, likely vibrating and whipping through spacetime at relativistic speeds. Controlling it might involve using energy fields we can't yet conceive of to dampen its oscillations and pin it in place. Finally, they would need to manipulate its immense gravitational field to open a gateway. The process might involve bringing two strings close together or carefully bending a single string until its extreme gravity creates a closed loop, a tunnel through the multiverse. This wouldn't be a gentle quantum transition. It would be a monumental, deliberate passage. The first travelers might have flown a vessel along the gravitational contours of the string, allowing its unique spacetime geometry to guide them through a rift into a neighboring reality. This theory moves us from a quiet, probabilistic hop to an epic feat of cosmic engineering, suggesting that the first journey between worlds was less about discovery and more about construction, a testament to a civilization that learned to build roads not on land but between universes. While cosmic strings propose a bridge built by ancient engineers, our third theory suggests the universe itself may have provided the first gateway, hidden in plain sight within the most terrifying and enigmatic objects in the cosmos, black holes. This idea revolves around one of the most elegant solutions to Einstein's equations of general relativity, the Einstein-Rosen bridge, more popularly known as a wormhole. The mathematics suggests that the immense gravitational crush of a black hole, which warps spacetime into a one-way street to a point of infinite density called a singularity, might not be the end of the story. Instead, that singularity could theoretically be bypassed with the black hole's tunnel, or throat, connecting to a white hole in another universe. A white hole is the exact theoretical opposite of a black hole, where a black hole's gravity is so intense that nothing, not even light, can escape its pull. A white hole would be a region of spacetime from which energy and matter can only pour out. Nothing could ever enter it. It would be a cosmic fountain, endlessly spewing material into its new reality. The connection forms a perfect natural portal. The black hole is the entrance, and the white hole in a parallel universe is the exit. This isn't just wild speculation. It's a valid, though highly debated, solution to the complex equations that describe gravity. But the challenge of surviving such a journey is monumental. The environment inside a black hole is notoriously hostile. Any traveler would be subjected to the extreme effects of spaghettification, the intense tidal forces stretching their body into a long, thin stream of atoms long before reaching the theoretical bridge. Furthermore, most theoretical models of wormholes are incredibly unstable. The tunnel would likely pinch shut faster than light could travel through it, collapsing the passage and crushing anything inside. For this to be a viable travel method, something would have to hold the tunnel open, perhaps a form of exotic matter with negative energy density that counteracts gravity's crushing force. So how might the first travelers have discovered and utilized this cosmic shortcut? It's unlikely they simply jumped in hoping for the best. A more plausible scenario involves an incredibly advanced civilization that had mastered the art of gravitational astronomy. They might have detected peculiar radiation or gravitational waves emanating from a supermassive black hole at the center of their galaxy, signals that hinted at a stability or structure contrary to known models. Perhaps they developed probes made of indestructible material or encoded their consciousness into robust data streams able to withstand the journey, sending them into the black hole's maw. The first successful transmission back, a message from another reality describing the white hole exit, would mark the historic moment of discovery. This theory paints the first journey not as an act of creation, but one of exploration and courage, of finding a door that the universe itself had already built and then finding the key to walk through it. Moving from the violent tunnels of black holes, our fourth theory invites us into an even stranger and more expansive realm, one where our entire universe is just a single page in an infinite dimensional book. This is the world of brane cosmology, a cornerstone of string theory. The word brane is short for membrane, and the idea is that our four-dimensional universe, 3 dimensions of space and 1 of time, is not all there is. Instead, it might be a 3-dimensional brane existing within a higher dimensional space known as the bulk. And just like pages in a book, other branes, each hosting their own separate universe with potentially different physical laws, could be floating right alongside ours in this higher dimensional void. The foundation for this incredible idea comes from string theory, which proposes that the fundamental building blocks of reality are not point-like particles but unimaginably tiny, vibrating strings. For the mathematics of string theory to work consistently, it requires more than the 4 dimensions we experience, often 10 or even 26. These extra dimensions are thought to be curled up or compactified at scales so small we cannot perceive them. Brane theory takes this a step further, suggesting that our entire universe is confined to a 3-dimensional brane, and that the forces we know, like electromagnetism and the nuclear forces, are also stuck to our brane. Only gravity, uniquely, is thought to be able to leak out into the bulk, which is one reason why it appears so weak compared to the other fundamental forces. So how could a journey between these membrane universes occur? The most dramatic possibility is a brane collision. If 2 branes are floating in the bulk, they might occasionally drift toward each other and collide. The energy released in such a cataclysmic event would be beyond imagination, potentially creating new universes or rebirthing old ones. Some cosmologists even suggest our own Big Bang was the result of such a collision. For a brief, universe-shattering moment, the boundary between realities would be torn open, creating a temporary portal. The first travelers might not have engineered this event but rather survived it, finding themselves cast from their home brane into the bulk during the collision, and then being deposited onto a neighboring brane when the forces subsided. A more controlled method would involve not waiting for a random collision but actively finding a way to detach from one's home brane and navigate the bulk. This presents a monumental challenge. First, a civilization would need to develop a technology to unstick themselves from the three spatial dimensions of their brain. This could involve creating a stable bubble of space-time around a vessel, a region where the local laws of physics are altered just enough to allow movement into a higher dimension. Then they would need a means of propulsion within the bulk. Since only gravity operates there, their engine might work by manipulating gravitational fields, creating waves in the bulk to sail upon. The navigation would be the ultimate challenge. How do you chart a course through a dimension you cannot see or comprehend, toward a destination you can only theorize exists? They might use gravitational anomalies, subtle tugs from neighboring brains, as their guiding stars. The first successful crossing would be less like a voyage across an ocean and more like a blind leap from one page of a book to another, a journey that redefines the very meaning of exploration. But what if the very first journey wasn't a voyage of ships or the engineering of cosmic bridges, but a journey of the mind itself? Our fifth theory ventures into perhaps the most radical and intimate possibility, that the inaugural crossing between universes was achieved not with technology but through pure consciousness. This idea pushes beyond conventional physics and into the provocative intersection of quantum mechanics, neuroscience, and ancient philosophical practices. At its heart is the quantum consciousness hypothesis, which suggests that the human mind isn't merely a biological computer, but might be intrinsically linked to the fundamental quantum processes that underlie reality. Proponents of this view point to mysteries like the nature of subjective experience and the process of wave-function collapse, proposing that consciousness itself could be a quantum phenomenon. If consciousness is indeed quantum in nature, then it might not be entirely confined to a single brain or a single universe. According to the many worlds interpretation, every quantum decision spawns a new branch of reality. A mind deeply attuned to its own quantum processes could, in theory, achieve a state of coherence or resonance with these other branches. The mechanism for this incredible feat could be twofold, blending the ancient with the ultra-advanced. On one path, we find the mastery of deep meditative or psychedelic states. For millennia, mystics and shamans have reported experiences of transcending the self and perceiving other realities. What if these weren't just hallucinations but brief, unstable glimpses into adjacent universes, achieved by quieting the brain's noise enough to perceive the faint signal of another existence? The other path is technological. An immensely advanced civilization might develop a device, a consciousness amplifier or a quantum resonance inducer, that can precisely align an individual's brainwaves with the quantum signature of a target universe. This wouldn't involve moving atoms. It would be about shifting the seat of awareness. The traveler's body would remain in their home reality, perfectly intact, while their subjective experience, their very sense of self, would suddenly be observing the world through the senses of their alternate self in another universe. The first successful trip might have been accidental, a scientist in a deep state of focus during a delicate quantum experiment, suddenly finding themselves seeing a lab that was almost identical, but with one crucial, terrifying difference. Evidence for such a theory would be infuriatingly elusive but not entirely absent. It could manifest as anecdotal accounts throughout history of people experiencing vivid, coherent memories of lives they never lived or premonitions of events that never came to pass in this timeline. In a modern context, it might appear as measurable, repeatable anomalies in brain scan data during specific altered states, showing neural activity that correlates with theoretical models of quantum tunneling. The beauty of this theory is that it suggests the barrier between worlds is not one of energy or distance, but of perception. The first traveler didn't need a spacecraft. They simply needed to learn how to truly listen, turning their awareness inward to find the doorway out. Leaving behind the ethereal realm of consciousness, our sixth theory grounds us once more in the tangible, yet no less strange, world of quantum materials. This idea proposes that the first trans-universal journey was not a leap of faith or a voyage through the bulk, but a feat of precise cosmic engineering made possible by one of the most peculiar states of matter ever discovered, the time crystal. Unlike all other matter we know, a time crystal breaks not just spatial symmetry, but time symmetry as well. Imagine a clock that ticks forever without any batteries, springs, or winding. Its perpetual motion isn't powered by stored energy, but is an intrinsic, stable property of its quantum structure. That is the essence of a time crystal. It's a system in its lowest energy state that still oscillates in a repeating, predictable pattern without ever losing energy to friction or heat. The profound implication of this is that a time crystal exists in a state that is permanently out of equilibrium with the rest of the universe, yet it remains perfectly stable. Its oscillations are a fundamental part of its existence, a rhythm baked into the fabric of reality at the quantum level. Now, let's scale this idea up to a cosmic level. The many worlds interpretation suggests that every quantum event causes the universe to branch. While these new universes diverge, they share a common origin point, the same foundational quantum rhythm from the moment of their birth. The revolutionary idea here is that a sufficiently large and complex time crystal could, in theory, act as a tuning fork for reality itself. Its immutable oscillation could resonate with that shared foundational rhythm in a parallel universe, even as the two realities drift apart due to differing quantum choices. The technological application of this would be the ultimate exercise in precision. A civilization advanced enough to harness this would first need to grow a macroscopic time crystal of immense complexity and stability, a material science challenge far beyond our current capabilities. This crystal would need to be tuned not to a frequency of sound or light, but to the specific quantum signature of a target universe. How would they even know what to tune it to? They might use a form of quantum archaeology, studying the subtle imprints of early universe events to reverse engineer the initial conditions that define their reality's unique oscillation. Once tuned, the time crystal device wouldn't create a physical tunnel or warp spacetime. Instead, it would create a zone of resonant synchronization around it, a bubble where the laws of physics from two universes briefly and perfectly align. Within this bubble, the boundary between here and there would become blurred. An object passing through this synchronized field might not feel like it's traveling at all. It might simply phase into the parallel universe as if it had always been there, because within that moment of perfect resonance, the two locations are effectively the same point. The first journey might have been a cautious experiment, a probe placed inside the resonance field suddenly reporting data that was utterly impossible according to all known laws of physics in our universe, its very atoms having become quantumly entangled with a duplicate probe in another reality. This theory suggests that crossing the multiverse isn't about brute force or immense energy, but about listening to the silent, eternal rhythm of creation and learning to sing in perfect harmony with a universe that is singing the same song, just in a different key. Building on the idea of synchronicity, our seventh theory dives into the greatest mystery of modern cosmology, proposing that the key to the first journey lies in harnessing the very force that is relentlessly pushing our universe apart. This theory centers on dark energy, the enigmatic phenomenon responsible for the accelerating expansion of the cosmos. We know it exists because of its overwhelming gravitational effect on the universe's large-scale structure, yet its true nature remains one of science's most profound puzzles. Imagine a force inherent to the vacuum of space itself, a kind of anti-gravity that grows stronger as the universe expands, ensuring galaxies will eventually recede from one another at speeds that make future observation impossible. The revolutionary idea here is that this same force, which creates vast cosmic deserts between galaxies, might also be the very thing that weakens the boundaries between universes. Think of the fabric of spacetime not as a single sheet, but as a stack of membranes, each a separate universe. dark energy's outward pressure, stretching each individual membrane, could simultaneously be thinning the gaps between them. In this model, the bulk, the higher dimensional space between branes isn't empty, it's infused with this repulsive energy. As dark energy drives the universes to expand internally, the space between them might become less substantial, more permeable. A civilization wouldn't need to generate unimaginable power to puncture a hole. They might simply learn to amplify this natural, pre-existing thinning process. The technological challenge of manipulating dark energy is almost beyond comprehension, as it would require a mastery over the vacuum of space itself. Current physics suggests that dark energy could be linked to the cosmological constant, an energy density inherent to empty space. To manipulate it, a civilization might need to learn how to locally alter the properties of the quantum vacuum. This could involve creating enormous, precisely configured energy fields to somehow cancel out or focus the repulsive effect of dark energy in a specific location. The machinery for this wouldn't be a traditional engine. It might look more like a colossal, stationary resonator designed to vibrate in harmony with the fundamental frequency of space-time, coaxing the dark energy to behave in a new way. If successful, this resonant manipulation wouldn't tear a hole but would instead generate a gradual, stable thinning, a windowpane becoming a soap bubble. At the epicenter of this effect, the barrier between realities would become translucent, then permeable. The first passage might not be a violent transition but a gentle drift, as the fundamental forces that bind particles to one universe weaken enough for them to be gently pulled into the gravitational influence of the adjacent one. The travelers might witness their destination universe slowly coming into focus around them, like an image resolving on a screen, until they find themselves completely enveloped by a new set of physical laws. This theory suggests the first journey was an act of sublime cosmic artistry, not forcing a door open but persuading the wall itself to gracefully dissolve. If the idea of resonating with a universe's rhythm seems abstract, our eighth theory offers a pathway that is both technologically tangible and rooted in a quantum phenomenon we can already observe in labs today: quantum entanglement. This bizarre connection, which Albert Einstein famously dismissed as spooky action at a distance, describes how two particles can become inextricably linked, their fates intertwined regardless of the physical distance separating them. Change the property of one like its spin, and its partner instantaneously reflects that change, even if it's on the other side of the galaxy. This instantaneous communication seems to violate the cosmic speed limit set by light, suggesting a deeper, hidden layer of connectivity within the fabric of reality. Now take this strange connection and project it onto a multiversal scale. The theory posits that if particles can be entangled within our universe, perhaps the same fundamental principle could be stretched to connect particles across the very boundaries of reality. This wouldn't be a network of wires and signals. It would be a living web of quantum correlations, a subatomic internet linking one universe to another. The first step wouldn't be transporting a person or a ship, but something far more fundamental: information. A civilization could establish the first contact by creating a pair of entangled particles and then, through a monumental feat of physics, somehow transfer or tunnel one of them into an adjacent universe. While the how of that initial transfer might rely on another method, like a focused quantum tunneling event, the result would be revolutionary: a single, stable particle acting as a trans-universal receiver and transmitter. Maintaining this connection is the primary challenge. Entanglement is notoriously fragile in our environment. Any interaction with the outside world, a single stray photon, can cause decoherence, breaking the magical link and collapsing the connection. To preserve an entanglement bridge between universes, the particles would need to be placed in a state of perfect isolation, likely within incredibly sophisticated quantum computers operating at near absolute zero. The civilization would need to master error correction on an unimaginable scale, creating a network of these entangled pairs to send complex data. The first messages wouldn't be words or images, but pure quantum states, the yes or no of a qubit. A successful transmission would be the ultimate proof, receiving a confirmed quantum state that could only have been sent from a reality with a different quantum history. This information network could then evolve into a travel technology. If you can send quantum information, could you send a blueprint? The concept of quantum teleportation, which we are already experimenting with, involves scanning the exact quantum state of a particle and transmitting that information to reconstruct the particle elsewhere. Scale this idea up to an unimaginable degree. A traveler wouldn't be physically hurled through a portal. Instead, their entire quantum state would be meticulously scanned, converted into data, and beamed through the entanglement network to a receiver in the parallel universe. There, a complex assembly of raw materials and energy would use that data to reconstruct the traveler, atom by atom, memory by memory, exactly as they were. The original version might be disassembled in the process, making it a one-way trip or perhaps preserved, leading to profound philosophical questions about identity. The first journey via this method would be the ultimate act of faith, stepping into a scanner, trusting that on the other side of reality, a perfect copy of you will open its eyes and take its first breath in a brand new world. While the idea of manipulating dark energy or quantum entanglement presents a technological future, our ninth theory looks back to the very birth of the cosmos for a doorway. This concept takes us to the very edge of our understanding of the universe's origin, to a fraction of a second after the Big Bang known as the inflationary epoch. Cosmologists believe that during this unimaginably brief period, the universe underwent a faster-than-light exponential expansion, smoothing it out and planting the seeds for all future galaxies. But what if this violent, primordial process didn't just create our universe, but also left behind scars natural, ready-made passageways to others? These hypothetical remnants are thought to be more than just cosmic fossils. They could be the ultimate shortcuts. The math of inflationary cosmology suggests that as the infant universe stretched at a phenomenal rate, quantum fluctuations were also being magnified to cosmic scales. Within this turbulent, energy-dense environment, it's possible that topological defects, knots in the fabric of space-time, formed and were subsequently stretched to enormous sizes. Some of these defects could have taken the form of primordial wormholes, tunnels threading through the newly formed multiverse. Unlike the unstable wormholes that might form in black holes today, these would be true relics, woven into the foundational structure of reality from its first moments, potentially making them far more stable. Finding one of these ancient structures would be the ultimate archaeological dig. They wouldn't be visible to optical telescopes. Instead, cosmologists would search for their gravitational signatures. A primordial wormhole, depending on its size and nature, might create a unique distortion in the cosmic microwave background, the afterglow of the Big Bang, appearing as a strange, circular cold spot or an unusual pattern of polarization. Alternatively, its gravitational lensing effect would be bizarre. Instead of distorting the image of a distant galaxy into an arc or an Einstein ring, it might create a perfect duplicate image or a ring of light with nothing visible at its center. Discovering such an anomaly would send shockwaves through the scientific community. Stabilizing such a passage would be the next monumental challenge. A natural inflationary wormhole might still be prone to collapse. The process of making it traversable could involve a technique similar to the one proposed for black hole wormholes, but with a fascinating twist. Instead of needing to generate exotic matter, the travelers might discover that the wormhole's inflationary era composition already contains a form of false vacuum energy or a unique quantum field that naturally opposes collapse. Their technology wouldn't need to create a stabilizing force from scratch, but rather wake up this dormant property, perhaps by sending a specific frequency of energy or a coordinated quantum vibration down the tunnel to resonate with its primordial structure. Journeying through such a passage would be like stepping into a living museum of creation. The walls of the wormhole wouldn't be made of rock or metal, but of space-time itself, potentially still echoing with the immense energies of the inflationary epoch. Travelers might witness phantom images of the universe's first moments flickering around them not as a historical recording, but as a real residual energy effect. The exit would not necessarily deposit them in a fully formed universe like our own. They might emerge into a reality that is still cooling, where the laws of physics are slightly different, or into a universe that branched off at such an early point that it is utterly alien. This theory suggests the first travelers were not engineers who built a bridge, but archaeologists who discovered the universe's first and greatest monument and learned how to open its doors. If manipulating energy or matter seems like a monumental task, our 10th theory proposes an even more fundamental approach, suggesting the key to the multiverse isn't a physical force but a conceptual language. This idea is rooted in the mathematical universe hypothesis, most famously proposed by cosmologist Max Tegmark. In its most radical form, this hypothesis doesn't just say the universe is described by mathematics, it posits that the universe is mathematics. Our physical reality, with all its particles, forces, and dimensions, is not just running on a mathematical code, it is a complex mathematical structure. And if that's true, then every other self-consistent mathematical structure also exists as a physical reality somewhere. A universe governed by completely different equations, with different numbers of spatial dimensions or alternative laws of physics, isn't just possible, it is inevitable. The multiverse, in this view, is a vast landscape of mathematical possibilities, each one a valid and existing reality. The breathtaking implication for travel is that moving between these realities wouldn't require tunneling through space or building cosmic bridges. It would require achieving a profound mastery over the language of reality itself. The mechanism wouldn't be an engine, it would be a proof. A civilization that reached the pinnacle of mathematical understanding wouldn't see a rock, a star, or a person as physical objects, but as incredibly complex interacting equations. To them, a mountain isn't just a mass of rock. It's a specific solution to a set of differential equations describing gravity and atomic bonding. To travel to another universe, they wouldn't move the mountain. They would carefully, precisely, re-solve the equations that define it. The technological implementation of this is almost impossible to visualize with our current understanding. It might involve a computer of unimaginable power, but not one that calculates numbers. This would be a reality manipulation engine, a device that can directly interface with the underlying mathematical code of our universe. It wouldn't use energy to force a change. It would use a logical argument to persuade reality to be something else. The process might begin by defining the target universe not by its coordinates, but by its axiomatic foundation, the core set of mathematical rules that define its existence. The device would then execute a transformation function, a kind of cosmic mathematical operator that maps the objects in our universe onto their equivalent states in the target mathematical structure. The experience of this journey would be unlike any other. There would be no tunnel, no sudden jump. From the perspective of the traveler, their local reality would begin to recalculate. The constants of nature might subtly shift. The color of light could change as the fine structure constant is rewritten. The very sensation of gravity might alter as the geometry of space-time is redefined around them. They wouldn't feel like they were moving, but like the universe was transforming to meet a new set of rules. They would be the same coherent mathematical structure, but now existing within a different system of equations. The first successful test might have been a small, contained area where the value of pi was experimentally changed, or where cause and effect temporarily operated in reverse, proving that the very axioms of existence were malleable. This theory suggests that the first travelers were not astronauts or engineers, but the ultimate mathematicians who learned that to explore new worlds, you don't need a ship, you need a better equation. But what if the first travelers didn't find a door or build a bridge, but instead chose to burn down their own house to escape it? This brings us to our 11th theory, one of the most perilous and existentially daring ideas on our list: the intentional triggering of a controlled vacuum metastability event. To understand this, we must first grasp the unsettling concept that the foundation of our reality might be built on a lie, or more accurately, a false vacuum. The vacuum of space isn't truly empty. It's seething with quantum fields that dictate the behavior of particles and forces. The current state of these fields gives us the laws of physics as we know them. However, some theories suggest our universe's vacuum state is not the lowest possible energy state it could be in. It's metastable, temporarily stable, like a ball resting in a small dip on the side of a much larger valley. It's comfortable here for now, but a sufficiently powerful nudge could send it rolling down into the true, absolute minimum of the valley, a state known as the true vacuum. A spontaneous transition to this true vacuum would be the most catastrophic event imaginable. It would not be an explosion in space, it would be an explosion of space. A bubble of this new, true vacuum would form at some random point in the universe and expand outward at the speed of light. As it expands, it would rewrite the very laws of physics within its sphere. The fundamental constants that allow atoms to form, nuclei to bind, and life to exist would be permanently altered. From our perspective, everything hit by this bubble would simply cease to be, instantaneously and without warning, replaced by a new reality governed by entirely alien rules. This is not science fiction, it's a legitimate, though highly speculative, worry in modern cosmology. Now, imagine a civilization so advanced, so confident, and perhaps so desperate that they decided not to fear this event but to control it. Their goal wouldn't be universal annihilation, but precision engineering. The theory posits that they could learn to trigger an infinitesimally small vacuum decay event and crucially contain it. They wouldn't create a planet-sized bubble, they would create a microscopic one, perhaps no larger than a single atom, and use immensely powerful energy fields to act as a perfect barrier, preventing the new physics from propagating outward and consuming their entire universe. Within this perfectly contained microscopic bubble, the laws of physics would be those of the true vacuum, and here's the revolutionary leap. If the many worlds interpretation is correct, this new set of physical laws might not be random. It could be the laws of a specific, adjacent parallel universe. The bubble wouldn't just be a region of new physics, it would be a literal plug of another universe surgically implanted into their own. Creating this bridge would be the ultimate high-wire act. The technology required would involve energies comparable to those at the very beginning of the Big Bang, likely needing a particle accelerator of planetary scale or a method to focus the energy of multiple black holes. The containment field would have to be perfect, a flawless reflection shield that not even information in the form of new physics could penetrate. A single miscalculation, a nanosecond of field failure, and the experiment wouldn't just end in a local accident. It would unleash an irreversible wave of change that would erase their entire cosmos from existence, replacing it with something unknowable. The reward for such an insane risk, however, would be unparalleled. Once the stable bubble of true vacuum is contained, it represents a direct point of contact with another reality. The boundary between the two universes would be this energy field, a shimmering wall separating two entirely different sets of existence. Travel through this gateway would be a one-way trip into the unknown. A probe sent into the bubble would not be traveling through space, it would be transitioning into an entirely new framework of reality. The moment it passed the containment field, its very atoms would be reconfigured according to the new laws. It might instantly vaporize, or it might stabilize into a form that could survive in that alien environment. The data sent back, if it could even be transmitted across the fundamental law barrier, would be the first direct information from another cosmos. The first travelers would be the ultimate pioneers, voluntarily stepping through a door that, if it ever widened by even a fraction, would mean the end of everything they had ever known. Their journey would be a testament to a breathtaking level of technological prowess and a profound, perhaps terrifying, willingness to gamble all of existence for the chance to touch what lies beyond. Yet for all its promise, the path to a unified theory remains our greatest scientific challenge, a mountain whose peak is still shrouded in clouds. The primary obstacle is one of scale. Quantum mechanics exquisitely describes the very small, the world of atoms and particles, while general relativity masterfully governs the very large, the realm of stars and galaxies. But at the event horizon of a black hole, or in the first moments of the Big Bang, where immense gravity acts on a quantum scale, the two theories produce nonsensical answers, their mathematics breaking down into infinities. This tells us we are missing a deeper layer of reality, a set of rules that seamlessly blends the quantum with the gravitational. Leading candidates like string theory and loop quantum gravity offer different visions of this unified framework. String theory proposes that the fundamental building blocks of reality are not point-like particles but unimaginably tiny, vibrating strings, with their different vibrations corresponding to different particles and forces. Gravity, in this view, is just another vibration in the string orchestra. Loop quantum gravity, on the other hand, suggests that space-time itself is not smooth and continuous but is made of discrete, indivisible units, tiny loops woven into a fabric, much like a piece of cloth is woven from individual threads. In both cases, the goal is the same: to describe gravity using the language of quantum physics. The profound implication for multiverse travel is that a complete theory of quantum gravity wouldn't just describe our universe, it would inherently describe all possible universes and, crucially, the connections between them. It would be the ultimate cartographer's map, not just of a single continent, but of the entire archipelagos of reality. This leads us to the concept of gravitational singularities. In Einstein's general relativity, a singularity is a point of infinite density and zero volume where the laws of physics as we know them cease to exist. The center of a black hole is the classic example. But most physicists believe this infinity is really just a placeholder, a sign that relativity is incomplete. A working theory of quantum gravity would replace this mathematical nightmare with a physical description. It might show that a singularity isn't an end but a transition, a knot in the fabric of spacetime that, when understood with the correct quantum grammar, unravels to reveal a connection to another part of the fabric. In essence, a black hole's heart might not be a dead end but a quantum gravity bridge. So how might such a bridge function? The mechanism would be far more stable and natural than the fragile wormholes of classical physics. Instead of needing exotic matter to prop open a tunnel, a quantum gravity bridge would be a fundamental feature of the spacetime geometry, revealed only when you have the right equations to decode it. Navigating it would be the ultimate application of unified physics. You wouldn't pilot a ship through it like a starship navigating a corridor. That would be applying classical thinking to a quantum realm. The journey would be more akin to quantum teleportation or a state change. A vessel would need to be able to interact with the quantum foam of spacetime itself, perhaps by generating a field that allows it to tune itself to the specific vibrational frequency of the bridge. Entering the bridge might involve the ship and its passengers undergoing a temporary phase shift, decohering from our universe and recohering in the new one, guided by the quantum gravitational forces that bind all realities together. The first travelers to use such a bridge wouldn't be explorers in the traditional sense. They would be applied physicists executing a flawless experiment based on a profound and beautiful theory, stepping through a doorway that was always hidden in plain sight within the mathematics of the cosmos. This brings us to a theory that places the power of the multiverse not in a machine, but within the mind itself. Theory 13 explores the provocative idea of consciousness-induced collapse, suggesting that the very act of observation might be the ultimate tool for navigating the infinite branches of reality. To understand this, we must first confront one of the most enduring mysteries in all of physics, the quantum measurement problem. In the bizarre world of quantum mechanics, particles don't exist in a single, definite state until they are measured. Before observation, they exist in a blur of all possible states simultaneously, a superposition described by a wave function. The moment a conscious observer looks, this wave function seems to collapse and the particle chooses a single, concrete reality. The monumental question is, what causes this collapse? The conventional Copenhagen interpretation simply states that measurement does it, treating it as a fundamental rule. But a more radical view suggests that consciousness itself is the trigger, that the observer's mind is the active ingredient that forces a probabilistic maybe into a definite is. Now extrapolate this idea to a cosmic scale. The many worlds interpretation offers a different solution to the measurement problem. The wave function never actually collapses. Instead, every possible outcome of a quantum event does happen, but each one occurs in a newly branched parallel universe. In this view, the observer doesn't cause a collapse. They simply become aware of one specific outcome in one specific branch, while their other selves become aware of the others. The theory of consciousness-induced collapse merges these two ideas. It proposes that an advanced consciousness might not be a passive passenger on this branching journey, but an active pilot. With sufficient training and technological aid, a mind could learn not just to witness a single outcome, but to intentionally choose which branch of the wave function to experience, effectively selecting which universe it inhabits from moment to moment. The technological implementation of this would be a blend of deep neuroscientific understanding and quantum engineering. We're not talking about simple meditation, but about a device that could be called a quantum state selector or a conscious resonance amplifier. This technology would have two primary functions. First, it would need to monitor the brain with unimaginable precision, mapping the specific neural correlates that accompany a conscious observation event the exact moment a quantum possibility becomes a perceived reality. Second, and more crucially, it would need to feed information back into the brain, not as sensory data, but as a direct quantum influence. It would gently bias the outcome of quantum events within the brain itself, creating a feedback loop where a conscious intention could guide the collapse of the wave function in a preferred direction. The experience of travel via this method would be utterly seamless and instantaneous. There would be no portals, no tunnels, no disassembly and reassembly. A traveler would simply form a clear, specific intention of the reality they wish to experience, perhaps one where they are standing on a world with a green sky. They would activate the device, and in the very next moment they would find themselves there. From their perspective, they wouldn't have moved. The entire universe around them would have shifted to match their choice. The only evidence of the journey would be the change in their environment and the memory of their previous location. This method suggests that every moment of our lives is already a form of unconscious universe selection, as our observation randomly locks us into one branch of reality. The breakthrough would be in transforming that random process into a deliberate act of will, turning the human consciousness from a prisoner of probability into the architect of its own existence. While the concept of harnessing consciousness to choose our reality bends the mind, our 14th theory grounds us in a strange but measurable phenomenon happening right now, all around us and even through our own bodies. This idea centers on the most elusive and ghostly particles known to science, neutrinos. Billions of these subatomic wisps pass through every square centimeter of your body every second, coming from the sun, from distant supernova, and from the heart of our own planet. They are notorious for being almost impossible to detect because they rarely interact with ordinary matter. They are electrical phantoms that can fly through light years of lead without a single collision. But their most bizarre property, and the key to this theory, is something called neutrino oscillation. Discovered only a few decades ago, this phenomenon revealed that neutrinos are cosmic shapeshifters. As they travel through space, they don't remain a single type. They spontaneously morph between three different flavors: electron, muon, and tau neutrino. This is profoundly strange behavior. In the standard model of particle physics, such a transformation should be impossible unless neutrinos have mass, a property that was once thought to be zero. The discovery of oscillation forced a fundamental rewrite of our understanding, proving these ghosts have a tiny, non-zero mass, but the mechanism behind the oscillation itself remains a deep mystery. The prevailing explanation is that the three flavors we detect are not the fundamental states of the neutrino. Instead, they are quantum mixtures of three different mass states. As the neutrino travels, these mass states evolve at slightly different rates due to their different masses, and this internal quantum interference manifests as the particle cyclically changing its identity. Now, let's extend this idea into the multiverse. What if this oscillation isn't just an internal process? What if it's driven by an external influence? The radical proposal here is that the neutrino isn't just oscillating between its own flavors. It's briefly and weakly interacting with parallel universes as it travels. In this model, the different mass states of the neutrino aren't just abstract quantum numbers. They correspond to the particle's presence or resonance in a slightly different reality. The oscillation we observe in our detectors would be the observable effect of the neutrino spending a tiny fraction of its existence, leaking into these adjacent dimensions, picking up a different identity from each one before snapping back to our own. It would be a natural, subatomic form of universe hopping, happening countless times every second all across the cosmos. The technological leap, then, would be to take this faint, natural signal and amplify it from the quantum to the macroscopic scale. How could a civilization achieve this? The first step would be an astronomical one, finding a pure, intense source of neutrinos. The ideal candidate might be a core collapse supernova, where a dying star releases a staggering burst of these particles, more neutrinos than there are stars in the observable universe, all emitted in a few seconds. By precisely measuring the flavor composition of this neutrino burst over time as it travels across space, scientists could hunt for anomalies in the oscillation pattern that can't be explained by standard physics, potential fingerprints of multiversal interference. The next step would be to recreate and control this process. This could involve building the most powerful particle accelerator imaginable, one designed not to smash particles together, but to generate an incredibly dense, coherent beam of neutrinos all in a single quantum state, a neutrino laser. By firing this beam through a precisely tuned energy field, researchers might be able to lock the oscillation process, forcing a macroscopic region of space around the beam to resonate in sync with the particle's multiversal flickering. Within this resonant field, the boundary between realities would become blurred, not by immense force but by subtle synchronization. An object passing through this field wouldn't be torn apart. It might simply phase into the target universe as the local laws of physics gently shift to match those of the destination. The first journey might be achieved not by building a ship that travels, but by creating a bubble of space that is, for a fleeting moment, shared. But what if everything we see and experience, from the farthest galaxy to the feeling of the wind on your skin, is nothing more than an incredibly detailed illusion, a cosmic projection? This brings us to our 15th theory, an idea that sounds like it's straight out of science fiction, but is grounded in the complex mathematics of string theory and black hole physics, the holographic principle. The core of this astonishing concept is that our three-dimensional universe, with all its rich depth and volume, might actually be encoded on a two-dimensional surface that surrounds it, much like the information on a credit card's hologram, seems to have three-dimensional depth when it is, in fact, stored on a flat, two-dimensional strip. The origins of this principle are as fascinating as they are counterintuitive, emerging from a paradox about black holes. Physicists discovered that the maximum amount of information, or entropy, that can be contained within any region of space is not proportional to its volume, as one might expect, but to the surface area of its boundary. This is a profound revelation. It suggests that all the information needed to describe everything within a sphere, every particle, every force, every event, could be entirely encoded on the surface of that sphere, one bit of information per tiny Planck area. Our reality, in this view, would be a breathtakingly complex projection from this fundamental, lower-dimensional surface, a cosmic movie being played out for us with the illusion of depth. The implication for multiverse travel is nothing short of revolutionary. If our universe is a projection, then other universes would be different projections, perhaps from the same fundamental surface or from adjacent ones. Traveling between them wouldn't require crossing vast stretches of higher dimensional space or building colossal engines. Instead, it would be about accessing and rewriting the source code of reality itself. The mechanism would be the ultimate form of programming. A civilization wouldn't build a spaceship, they would develop a reality compiler, a technology capable of directly interfacing with the two-dimensional information layer that underlies our three-dimensional existence. The technological implementation of this would involve a mastery over information and energy that is almost godlike. First, they would need to find a way to read the cosmic code. This might be achieved at the boundaries of our universe, perhaps at the event horizon of a supermassive black hole, where the holographic encoding of information is theorized to be most apparent. By studying the quantum information that falls into a black hole, a puzzle known as the black hole information paradox, they might reverse engineer the language of the projection. The next step would be learning to write to this source code. This wouldn't involve a keyboard or a screen, but something far more exotic, a device that can precisely manipulate the quantum states at the Planck scale, the smallest possible unit of space. This technology might use focused beams of energy or complex quantum fields to alter the fundamental bits of information on the cosmic hologram. The act of travel would be unlike any other method. A traveler wouldn't move through space to reach a portal. They would stand in one place while the device around them carefully rewrites their local information on the holographic surface, changing their coordinates not in our three-dimensional world, but in the source code that defines which universe is being projected. From their perspective, the world around them would simply change. The stars in the sky might rearrange into new constellations, the fundamental constants of nature might feel different, and they would find themselves in a new projection, a new universe, as if they had always been there. The first journey via this method would be the ultimate act of creation, proving that we are not just players in the universe, but that with enough understanding, we can become the authors of our own reality. Yet what if this faint glow from the dawn of time is not just a baby picture of our universe, but also a complex tapestry woven with threads from other realities? Theory 16 invites us to read this ancient radiation like a cosmic treasure map, searching for the subtle fingerprints of parallel universes. The cosmic microwave background, or CMB, is the remnant heat from the Big Bang, a bath of microwave radiation that fills every corner of the cosmos, detected as a static on old television sets. For cosmologists, it is the single most important source of data about the early universe, a snapshot from when the cosmos was just 380,000 years old. By studying the tiny temperature fluctuations in this radiation, patterns of hot and cold spots only a millionth of a degree in variation, scientists can deduce the universe's composition, its rate of expansion, and the seeds of all future structure. But some of these patterns are deeply puzzling. The most famous enigma is the CMB cold spot, a vast, unusually frigid region in the constellation Eridanus that is far larger and much colder than our standard models of the universe can easily explain. One compelling, though highly speculative, hypothesis is that this cold spot is not a feature of our universe at all, but the cosmic bruise left by a collision with another universe in the multiverse. The idea is that in the inflationary period, as our universe rapidly expanded, it may have bumped against a neighboring reality. This colossal impact would have drained energy from that region of our cosmos, leaving it significantly colder than its surroundings, an imprint frozen in time that has been traveling toward us for over 13 billion years. Finding such an imprint would be the discovery of the millennium, and the search is on. Astronomers use powerful space-based telescopes like the Planck satellite to create exquisitely detailed maps of the CMB's temperature and polarization. They don't just look for cold spots, they search for specific statistical anomalies in the patterns, strange alignments, unexpected asymmetries, or concentric rings of temperature variation that could indicate a past interaction with another gravitational source from outside our spacetime. It's the ultimate forensic investigation, searching for evidence of a crime, a collision with another universe that occurred before our universe was even fully formed. The leap from discovering such a bruise to using it as a portal is a monumental one. The theory suggests that these collision points, where the fabric of spacetime was once stressed and thinned by an external force, might represent permanent weak spots in reality's structure. The boundary between our universe and the one we collided with might be exceptionally fragile there, like a healed scar that never quite regained its original strength. A sufficiently advanced civilization wouldn't need to tear a new hole. They could locate one of these pre-existing scars and find a way to gently reopen it. The technology to achieve this would likely involve resonating with the unique quantum signature of the collision site. Just as a skilled opera singer can shatter a wine glass by matching its resonant frequency, a device could be built to generate vibrations in the fabric of spacetime that precisely match the frequency of the initial impact from eons ago. This wouldn't be a brute force attack on reality. It would be a delicate act of symphonic engineering, using energy to remind spacetime of a past trauma and coaxing it to peel open along the old fault line. The resulting gateway might not be a stable, permanent structure, but a temporary, shimmering window into the universe on the other side of that ancient collision, a view into the reality that once left its mark on our own. But what determines which of these countless possibilities becomes the solid, single reality we all collectively experience? This is the central question addressed by our 17th theory, a fascinating idea known as quantum Darwinism. In our everyday world, we seem to share a single objective reality. When you and a friend look at a chair, you both agree it's there. Its existence isn't a matter of probability. Quantum Darwinism proposes a mechanism for how this classical certainty emerges from the fuzzy quantum underworld. It suggests that the quantum states that are the most stable, the most robust, and the most able to copy themselves into the environment are the ones that get selected. They survive a process of natural selection, becoming the classical reality we all agree upon. Imagine a quantum system like a single particle that could be spinning either up or down. According to quantum Darwinism, this particle doesn't just interact with a measuring device. It interacts with the countless photons, air molecules, and other particles in its environment. These interactions create multiple redundant copies of information about the particle's state. The states that can create the most stable, widespread copies, like a robust meme spreading across the internet, are the ones that win out and become the perceived reality. The other possibilities don't vanish. According to the many worlds view, they simply decohere and branch off into their own separate, unobserved universes. The profound implication for multiverse travel is that this process might not be fixed. What if a civilization could learn to manipulate this quantum selection process? Instead of the environment passively choosing which state becomes real, they could actively intervene to promote a different outcome. The technology for this wouldn't be a colossal engine, but a device of exquisite subtlety, a quantum reality stabilizer. This device would work by controlling the decoherence process, carefully managing how a quantum system interacts with its environment to prevent the usual winner-take-all outcome. The mechanism might involve creating a perfectly isolated chamber where environmental interactions are not just minimized but precisely orchestrated. Within this chamber, a quantum system could be held in a prolonged state of superposition, its multiple possibilities kept alive and coherent. The stabilizer would then gently nudge the system, perhaps using targeted quantum fields to encourage a specific, less probable state to make more copies of itself in what little environment exists within the chamber. It would be like artificially breeding a rare quantum outcome, helping it outcompete the default reality. A successful experiment would see our object inside the chamber definitively manifest a property that was extremely unlikely, such as a radioactive atom failing to decay or a particle being in two places at once in a measurable classical way. Navigating to a parallel universe using this method would be a unique form of travel. There would be no physical portal to step through. Instead, the travelers would use the stabilizer to select a specific branch of reality, one where a key historical event had a different outcome, and then reinforce that selection until it becomes the new, stable classical reality for everyone within the field's influence. From their perspective, their local reality would smoothly transform around them. They wouldn't feel like they moved. It would feel like history itself was being rewritten in real time, with their memories updating to match the new timeline. The first journey would be the ultimate act of gentle persuasion, not forcing a door open but simply convincing reality to tell a different story, one that had always been waiting in the wings. While navigating the abstract concepts of quantum selection offers one path, our 18th theory brings us back to a tangible, albeit equally elusive, object predicted by the equations of physics, the magnetic monopole. In our everyday experience, magnets always have two poles, a north and a south. You can break a bar magnet in half, but you don't get isolated poles. You simply get two smaller magnets, each with its own north and south. The existence of a particle with just a single magnetic charge, a north without a south or vice versa, has been a holy grail of physics for decades. While never observed, these magnetic monopoles are not just speculative fiction. They are a robust prediction of grand unified theories which attempt to merge the electromagnetic, weak, and strong nuclear forces into a single framework. These theories suggest that monopoles would have been created in unimaginable abundance during the extreme energies of the very early universe, a fraction of a second after the Big Bang. They would be incredibly massive particles, perhaps as heavy as an entire bacterium compressed into a single point, making them more like miniature black holes than typical subatomic particles. Their most striking property would be their immense magnetic charge, which would be quantized and fundamentally different from anything we've seen. Finding one would not just be a new discovery, it would be a monumental validation of our most ambitious physical theories, providing a direct window into the forces that shaped the cosmos at its birth. But their potential goes far beyond simply completing a textbook diagram. The profound twist comes from the work of physicists like David Bohm and later researchers who explored the quantum mechanics of these hypothetical objects. Their calculations revealed something astonishing. The field around a magnetic monopole could have incredibly unusual geometric properties. It could twist the fabric of spacetime around it in a way that creates a stable, natural wormhole. Unlike the volatile and short-lived wormholes predicted in other contexts, a monopole wormhole might be inherently stable, its structure held open by the unique and powerful topology of the monopole's magnetic field. It wouldn't require exotic matter to prevent its collapse. Its very nature would be the exotic matter. This leads to a breathtaking possibility. What if these primordial relics forged in the first moments of time are not just particles but natural connection points, cosmic buttons that link our universe to others? In this model, a monopole isn't something you would put into a machine to create a portal. The monopole itself is the portal, or at least one end of it. The other end would logically be connected to its antimatter counterpart, an anti-monopole which could reside in a completely different universe. They would form a perfect, stable bridge through the multiverse, a permanent tunnel created by the universe itself during its initial phase transitions. The challenge, of course, is first finding one. A magnetic monopole of such mass would be moving relatively slowly through the galaxy, and its immense magnetic charge would leave a distinctive trail of ionization like a cosmic fingerprint. Experiments have been searching for decades using sophisticated detectors deep underground, but the vastness of space means they are likely extremely rare. An advanced civilization might not wait for one to drift by, they might attempt to create one. This would require energies far beyond any particle collider we can envision, perhaps by colliding heavy nuclei at near-light speeds in an accelerator the size of a solar system, or by harnessing the turbulent energy of a neutron star merger, recreating a sliver of the conditions that existed at the universe's birth. If a civilization could either locate or create a monopole, the next step would be learning to activate and control it. They wouldn't need to move the massive object itself. Instead, they might build a complex containment facility around it, a stellar-scale laboratory designed to feed energy into the monopole in a precise manner. By applying specific electromagnetic or gravitational waves, they could theoretically ring the monopole like a bell, exciting its quantum states and causing the connected wormhole to dilate and become traversable. The entrance might manifest as a shimmering sphere of distorted light and magnetism surrounding the stationary monopole. A vessel designed to withstand the immense forces could then navigate this magnetic maelstrom, not by conventional propulsion, but by allowing the structured field to guide it through the stable throat of the wormhole and out the other side, into a universe where the laws of physics might be subtly or dramatically different. The first journey through a monopole gate would be less about engineering a new technology and more about learning to use the universe's own ancient, pre-installed doors. But what if the key to unlocking the multiverse isn't found in a colossal machine or a cosmic string, but within the deeply personal landscape of your own mind? This brings us to our 19th theory, a profoundly philosophical and intimate idea known as quantum Bayesianism or cubism. At its heart, cubism offers a radical reinterpretation of the fuzzy probabilities at the core of quantum mechanics. Where other interpretations see these probabilities as objective properties of particles, cubism argues they are something much more personal, degrees of belief. A quantum probability isn't a statement about what an electron is. It's a statement about what you, the agent, should expect will happen when you interact with it. It's a Bayesian probability, a subjective assessment based on your current knowledge and experience. In this view, the wave function isn't a real physical wave. It's a tool in the agent's toolbox, a mathematical device for structuring their expectations about the world. This shifts the entire narrative of quantum mechanics from a description of an external reality to a guide for navigating personal experience. The famous wave function collapse isn't a physical event happening out in the world. It's the moment you update your beliefs based on new information from an experiment. Now extend this personal, belief-centric view to the multiverse. If your reality is, in a very real sense, a construction built from your expectations and interactions, then what happens if you could perform a radical, wholesale update of your entire set of quantum beliefs? The theory proposes that such a profound shift in personal perspective might not just change how you see the world, but could literally relocate the conscious agent that is you to a parallel universe where those new beliefs are the consistent, objective reality. The technological path to achieving this isn't about building an engine, it's about building a catalyst for consciousness. We're not discussing simple positive thinking, but a rigorous, technology-aided process of cognitive restructuring. An advanced civilization might develop a reality-shifting interface, a device that combines deep neural monitoring with quantum state simulation. This technology would work in two phases. First, it would map a user's deeply held quantum beliefs, their subconscious expectations about how reality operates, built from a lifetime of sensory input. Second, it would immerse the user in a perfectly simulated reality where the laws of physics are subtly different, a controlled environment where their new desired beliefs are consistently reinforced as true. Through prolonged and precise exposure, the user's fundamental expectations about cause and effect would be rewired. Their internal quantum Bayesian map would be completely redrawn. The moment of transition would be the ultimate act of conscious observation. Upon reaching a critical threshold of belief adoption, the user would perform a final, definitive measurement on a quantum system, perhaps observing the spin of an atom or the path of a photon. According to cubist philosophy, this act of observation is where the agent personally participates in bringing a specific reality into being for themselves. With their beliefs now perfectly aligned with a different set of physical laws, their observation would not just confirm a new fact, it would be the final keystone that locks them into the consistent reality branch that matches their new expectations. From their perspective, they wouldn't travel. The entire universe would simply snap into a new configuration around them, one that had always been a potential branch but was now their experienced reality. The first individual to achieve this would be the ultimate pioneer of the mind, proving that the most powerful tool for exploring the multiverse is not a spacecraft, but the conscious self, capable of rewriting its own relationship with existence itself. Moving beyond the internal landscapes of belief, we arrive at a theory that grounds our journey in the elegant, if complex, mathematics of string theory. Our 20th idea explores the breathtaking possibility that the pathways to other universes aren't far away, but are curled up into a space so tiny we cannot perceive them, waiting for us to learn how to uncurl them. This is the theory of extra-dimensional navigation, and it begins with one of the most profound predictions of modern physics, that our universe may have more than the three spatial dimensions we experience every day. String theory, a leading candidate for a theory of everything, requires these extra dimensions for its mathematical consistency. Rather than the four-dimensional spacetime of Einstein's relativity, string theory posits a universe with 10 or even 26 dimensions. So where are they? The prevailing idea is that these extra dimensions are compactified or curled up at a scale so infinitesimally small, the Planck scale, that they are completely hidden from our view. Imagine a garden hose. From a great distance, it looks like a simple one-dimensional line. But if you could shrink down to the size of an ant and crawl onto its surface, you would discover it has a second dimension curled around its circumference. Our universe could be much the same. We are simply too large to perceive the extra dimensions curled up at every single point in space. The revolutionary proposal for travel is that these compactified dimensions aren't just abstract mathematical necessities. They could be the universe's ultimate subway system, with tunnels connecting distant stations, or in this case, parallel realities. If our brain is a three-dimensional membrane floating in a higher dimensional bulk, then the compactified dimensions could be like complex folds within that membrane. 2 points that seem impossibly far apart in our three-dimensional space might actually be adjacent when the fabric of reality is viewed through the lens of these higher dimensions. The distance between your hand and a parallel universe might not be measured in light years, but in the intricate geometry of these hidden coiled directions. Accessing and traversing this pathway is the monumental challenge. The first step would be to somehow uncurl or expand these tiny dimensions around a localized area. The energy required to do this is almost unimaginable, likely on the scale of recreating the conditions of the Big Bang itself. A civilization might achieve this not with a traditional engine, but with a dimensional resonance projector, a device designed to vibrate the very fabric of space-time at the specific harmonic frequencies that cause these compactified dimensions to briefly unfurl. Success would create a bizarre and beautiful phenomenon, a region of space where the classical laws of geometry break down. An object passing into this field might appear to twist and fold in impossible ways from our perspective as it begins to move through directions we cannot naturally see. Navigation through this higher dimensional space would be the ultimate test of intellect and perception. The travelers would not be pilots in a conventional sense, they would be geometers of the highest order. Their vessel would need to be equipped with sensors that could perceive and map the complex topology of the extra dimensions, translating that data into a form their three-dimensional minds could comprehend, likely through advanced virtual reality interfaces. The course wouldn't be plotted using stars, but by solving intricate mathematical problems in real time, charting a path through a multidimensional maze where a wrong turn could lead not to a distant star, but to a universe where gravity is repulsive or time flows backward. The journey itself might be instantaneous from our perspective, as moving through a higher dimension could allow them to bypass our conventional three-dimensional space entirely, taking a cosmic shortcut that renders distance meaningless. The first successful voyage would be a quiet, almost imperceptible event from the outside. A ship would enter the resonance field and simply vanish, not in a flash of light, but by fading into a direction we cannot point to. From inside the vessel, the experience would be utterly transcendent. The crew might witness their own universe receding not behind them, but above or below them in a dimension they never knew existed, while their destination universe grows in a direction that feels entirely new. Their arrival would be the reverse of their departure, the extra dimensions gently curling back up around them, leaving them solidly embedded in a new reality. This theory suggests that the greatest journeys aren't about going faster or farther in the space we know, but about learning to see the hidden dimensions that have been woven into the fabric of existence all along, turning the entire cosmos into a network of secret passageways just waiting to be explored. But what if the most significant barrier to crossing realities isn't a lack of energy, but a problem of information? This brings us to our 21st theory, which proposes that the first journey might not have involved moving physical matter at all, but rather transmitting its complete blueprint across the multiverse. The foundation for this incredible idea is being laid in laboratories today, not with people or spaceships, but WITH Chinese letter particles. Scientists have already successfully demonstrated quantum teleportation, a process where the exact quantum state of one particle, its unique identity, so to speak, is instantaneously transferred to another distant particle, all without either particle ever physically traveling the space between them. This isn't science fiction, it's a routine experiment that relies on the spooky connection of quantum entanglement. The process is both elegant and bizarre. It begins with two particles that are entangled, their fates linked. Let's call them photon A and photon B. If you want to teleport the quantum state of a third particle, photon C, to a distant location, you don't send photon C itself. Instead, you perform a special joint measurement on photon C and photon A. This measurement instantly destroys the unique states of both C and A, but it also causes photon B, no matter how far away, to instantly take on the exact quantum identity that photon C originally had. The information about C's state has been teleported to B using the entanglement link as a conduit. Crucially, the original photon C no longer exists in its previous form. Its essence has been moved. Now scale this idea up from a single photon to a human being. The theoretical limits are staggering. A human body is composed of more than 7 octillion atoms, each with a vast number of electrons, protons, and neutrons, all in specific quantum states. To teleport a person, you would need to scan and perfectly measure the quantum state of every single one of those particles simultaneously, a feat that would require a computer of literally unimaginable power and would likely violate the Heisenberg uncertainty principle, which states that you cannot know both the position and momentum of a particle with perfect accuracy. This scanning process would also, by its very nature, destroy the original arrangement of particles in the body you are scanning. This is the ultimate paradox of teleportation. To create a perfect copy elsewhere, you must dismantle the original. The challenge of maintaining entanglement across reality boundaries is even more profound. For quantum teleportation to work between universes, you wouldn't just need two entangled particles in the same reality. You would need one half of an entangled pair here and its partner already residing in the target universe. Establishing that initial trans-universal link is the monumental first step. One possibility is that rare, natural quantum fluctuations could cause a particle to briefly tunnel into an adjacent reality and become entangled with a particle there before snapping back, leaving behind a fragile, cross-dimensional link. A sufficiently advanced civilization might learn to detect, stabilize, and amplify these naturally occurring bridges. The technological implementation would be a two-part system. In the departure universe, an unimaginably complex array of quantum scanners would map the traveler, not by looking at each atom individually, but by performing a type of quantum state tomography on the entire structure at once. This information, which is essentially the complete recipe for reconstructing the traveler, would then be encoded into a signal and sent through the stabilized entanglement bridge to the receiver in the parallel universe. There, a system of equal complexity, stocked with a reservoir of raw atoms and energy, would use the transmitted blueprint to reassemble the traveler, particle by particle, memory by memory, exactly as they were. The first being to undergo this process would experience something beyond our comprehension. From their perspective in the departure chamber, the scan would begin and their consciousness might simply cease. In that same instant, for all practical purposes, their consciousness would flicker back into existence in the reception chamber of the parallel universe, in a body that is a perfect atomic duplicate. They would have no memory of travel because there was no journey, only a discontinuous jump from one point in reality to another. This theory suggests that the first trans-universal traveler didn't voyage through space, but was essentially faxed, their entire existence converted into the most important message ever sent. While dark matter remains one of the universe's greatest mysteries, its very invisibility might be the key to unlocking the multiverse. This brings us to a theory that reimagines dark matter not as a passive component of our cosmos, but as an active, living bridge to realities beyond our own. We know dark matter exists because of its overwhelming gravitational influence. It holds galaxies together and shapes the large-scale structure of the universe, yet it neither emits nor absorbs light, making it completely undetectable to our telescopes. It is the universe's hidden architecture, the unseen scaffolding upon which the visible universe is built. The revolutionary idea here is that this mysterious substance might not be entirely of our universe. Some cosmologists have proposed that what we perceive as dark matter could actually be the gravitational influence of matter residing in a parallel universe, subtly leaking into our own. Think of our universe and a neighboring one as two sheets of paper suspended very close to each other. Although the papers themselves don't touch, the gravity from one sheet can weakly influence the other, creating dimples and pulls that would seem to come from an invisible source within each respective sheet. In this model, the gravity we attribute to dark matter in our galaxy could be, in part, the gentle tug of stars and planets in a universe impossibly close yet entirely separate from our own. The path to harnessing this for travel begins with the monumental task of finally detecting and understanding dark matter directly. Experiments deep underground, like xenon-based detectors, are trying to catch the extremely rare moment a dark matter particle bumps into a regular atom. Others are looking for the unique signals dark matter might produce as it collects in the intense gravitational wells of stars or planets. But if the multiverse leakage theory is correct, the signature of dark matter would be even more peculiar. Astronomers might search for patterns in the distribution of dark matter that don't quite align with the standard models, strange, large-scale filaments or halos that seem to be shaped by a gravitational source from outside our spacetime, a subtle fingerprint of the adjacent universe's structure. The technological application of this knowledge would be the ultimate exercise in gravitational engineering. A civilization wouldn't need to generate immense energy to rip a hole in spacetime. Instead, they could learn to amplify this natural gravitational leakage. Imagine a device that acts as a gravitational resonance imager, designed not to look for light, but to map the incredibly faint gravitational waves and distortions that flow between universes. Once they pinpoint a location where this leakage is strongest, a soft spot in the fabric of reality, they could employ a kind of counter-gravity technology. By generating precise gravitational waves that are the exact opposite or inverse of the leaking gravity, they could create a zone of cancelled gravitational pull. In this bubble of nullified force, the boundary between universes, no longer held taut by competing gravities, might become slack and permeable. Transitioning through such a gateway would be a unique experience. There would be no violent tunnel or blinding light. The travelers might simply feel the sensation of gravity around them shifting, changing direction, and then dissolving entirely as their vessel begins to drift not through space, but through the softened barrier into the gravitational influence of the neighboring universe. They would be pulled gently into a new cosmos, arriving not with a bang, but with the quiet inevitability of an object finally succumbing to a force it has always felt but never seen. This theory suggests that the first journey between worlds was not an act of force, but an act of listening, of finally hearing the faint gravitational whisper of the universe next door and learning how to answer. Imagine a computer so powerful it doesn't just calculate numbers, but actively weaves the fabric of reality itself, simulating every atom, every force, and every moment of an entire cosmos within its quantum core. This isn't a distant dream. It's the logical endpoint of quantum computing, a field that harnesses the bizarre rules of the quantum realm to perform calculations millions of times faster than any conventional supercomputer. Where classical computers use bits that are either 0 or 1, quantum computers use qubits which can be 0, 1, or both simultaneously, a state called superposition. This allows them to explore a near-infinite number of possibilities at once. Now, project this technology forward 1,000 or 1,000,000 years. And civilization with such a machine wouldn't just be running complex models. They could be creating fully realized universes, complete with their own laws of physics and potentially even conscious beings, all existing as intricate patterns of information within the quantum computer's processing matrix. This idea is deeply intertwined with the simulation hypothesis, which posits that our own reality might be such a simulation created by a more advanced civilization. If that's the case, then the creators of such a simulation would, from our perspective, be gods. But for them, their simulation might be a form of science or art. The gateway theory takes this a step further. It suggests that if you can simulate a universe with perfect fidelity, the distinction between a simulation and a base reality might begin to blur and eventually vanish entirely. In a quantum computer, the simulation isn't just a pixelated representation. It's being rendered using the same fundamental quantum processes that underlie our own reality. The qubits aren't just storing data about an electron. In a very real sense, they are the electron for the duration of the simulation. This isn't a video game. It's the genesis of a new reality within a protected, computational environment. The mechanism for travel, then, becomes a form of targeted upload or download. A civilization wouldn't build a physical portal. Instead, they would develop an interface that can precisely map a conscious mind, the complex pattern of information that constitutes a person's memories, personality, and sense of self, and transfer that pattern into the simulated universe. The traveler's consciousness would be encoded into a data stream and injected into the simulation, where it would be instantiated within a simulated body. From their perspective, they would simply wake up inside the new world. The reverse process would also be possible. A simulated being could have its consciousness scanned and downloaded into a physical body in the creator's reality. The first journey would be the ultimate act of translation, converting the essence of a being from one substrate of reality to another. The philosophical implications of this are staggering and deeply unsettling. If you travel into a simulation, are you any less real? If a simulated being is brought into your reality, do they have rights? This technology would force a complete redefinition of identity, existence, and reality itself. It raises the possibility that our own universe could be a simulation, and that what we perceive as parallel universe travel might simply be accessing another server in a vast cosmic network of created realities. The first travelers might not be pioneers exploring the unknown, but simply users logging into a new environment, forever uncertain if their original home was ever the true base reality or just another layer in an infinite digital onion. We've explored the cosmos and dived into the quantum realm, but what if the most advanced technology required for multiverse travel is already inside us, evolved over millions of years? This brings us to a theory that is as intimate as it is profound, suggesting that life itself might be the universe's engine for exploring its own possibilities. Theory 24 proposes that biological systems, particularly the human brain, might already be performing subtle, natural interactions with parallel universes through quantum processes, and that enhancing these innate biological quantum effects could be the key to conscious travel. This idea sits at the thrilling intersection of two cutting-edge fields, quantum biology and neuroscience. Quantum biology challenges the long-held assumption that the warm, wet, and chaotic environment of a living cell is too messy for delicate quantum effects like coherence and entanglement to play a role. Yet, astonishingly, we now have solid evidence that nature has been leveraging quantum mechanics all along. The process of photosynthesis, for instance, relies on quantum coherence to achieve near-perfect efficiency in transferring energy from sunlight. Birds navigate using the Earth's magnetic field through a hypothesized quantum compass in their eyes, relying on the spin of entangled electrons. Even our sense of smell might be explained by the quantum vibrational theory, where receptors in our nose detect the subtle quantum vibrations of molecules rather than just their shape. If quantum mechanics is actively at work in these biological systems, the most exciting question is what role it plays in the brain, the seat of consciousness. The conventional model of the brain is that of a classical computer, with neurons firing like biological transistors. But this model struggles to explain the unity of subjective experience, the binding problem of consciousness, and the nature of free will. The Orch theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness arises from quantum computations happening within structures inside neurons called microtubules. These tiny protein frameworks could provide a protected environment where quantum superpositions can be maintained long enough to influence neural processes. In this view, every conscious moment is the collapse of a quantum wave function. Now, extend this idea to the many worlds interpretation. If each quantum decision in the brain leads to a collapse, it spawns a new universe. But what if, under certain conditions, that collapse isn't final? What if the brain can maintain a fragile quantum coherence not just within one universe, but across multiple branches of reality? This theory posits that our brains might already be doing this, albeit unconsciously. Those inexplicable moments of intuition, a powerful sense of déjà vu, or a sudden creative insight that seems to come from nowhere could be glimpses leakage from the conscious experience of your other selves in adjacent realities. Your brain isn't just a receiver of sensory input from this universe. It might be a multidimensional organ, constantly and subtly resonating with its own parallel versions. The technological application of this wouldn't involve building a machine from scratch, but rather learning to amplify and control a biological function we already possess. An advanced civilization might develop a consciousness resonance chamber, a device designed not to project energy outward but to turn inward, enhancing the brain's natural quantum coherence. This wouldn't be a helmet that zaps you with energy. It would be more like a sensory deprivation tank combined with the most advanced neurofeedback system ever conceived. It would perfectly shield the brain from external decohering noise, the random photons, sounds, and energies of our environment that constantly collapse quantum possibilities, while using targeted, gentle magnetic fields to encourage and sustain large-scale quantum coherence within the microtubules. The experience of travel through this method would be the most seamless of all. There would be no portal, no disassembly, and no sensation of movement. A traveler would enter the chamber, and through a combination of deep meditative focus and technological aid, they would guide their consciousness toward a specific intention, a desired reality. As the device amplifies their brain's quantum coherence, their perception would begin to shift. They might experience a lucid dreamlike state, but one that is objectively real, seeing overlapping possibilities from different universes. The final step would be a conscious act of will, a definitive choice that collapses this superposition of experiences into a single, stable reality. They would then simply open their eyes, still in the chamber, but now in a universe where their intention is manifest. The only proof of the journey would be the changed world around them and the unshakable knowledge that they had, through the power of their own amplified consciousness, selected their destination from the infinite tree of possibilities. This theory suggests that the ultimate vehicle for multiverse exploration has been with us all along, waiting for us to learn how to truly drive it. But if we shift our focus from the quiet quantum world to the most violent and energetic events in the cosmos, we find a theory that suggests the universe itself might be providing ready-made portals in a spectacular, fireworks-like display. Theory 25 takes us to the heart of a cosmic cataclysm so powerful it literally shakes the fabric of the universe, the collision of two neutron stars. These stellar corpses are among the most extreme objects in existence, each one the crushed core of a massive star that went supernova. A single sugar cube-sized piece of a neutron star would weigh as much as a mountain, and they spin at dizzying speeds, often emitting beams of radiation that make them detectable as pulsars. When two of these incredibly dense objects become locked in a gravitational embrace, they spiral inward over millions of years, eventually merging in an event that unleashes more energy in a few seconds than our Sun will produce in its entire 10 billion-year lifetime. The aftermath of such a collision is a forge of creation and destruction. It is within these events that most of the universe's heavy elements like gold, platinum, and uranium are thought to be forged and scattered into space. But beyond creating precious metals, the physics of such a merger is almost unimaginably extreme. The gravitational forces involved are so intense that they don't just warp space-time, they send powerful ripples through it known as gravitational waves. We have now directly detected these waves using observatories like LIGO and Virgo, and the signals from neutron star mergers have a very distinct fingerprint, a rising chirp that ends in a sudden, silent crash. It is within that final, silent moment of maximum density and distortion that some physicists speculate something even more extraordinary could occur, a temporary rupture in the very fabric of space-time. The mathematics of general relativity shows that at the point of collision, the density of matter and the curvature of space-time reach values that approach the singularity of a black hole. Under these conditions, the equations themselves begin to break down, suggesting that our current understanding of physics is incomplete. It is in this gray area, in the heartbeat between the merger and the formation of a new black hole, that a gateway could momentarily flicker into existence. This wouldn't be a stable wormhole held open by exotic matter, but a raw, violent tear caused by the sheer overwhelming force of the impact, a cosmic wound that might briefly connect to the multiverse before the newborn black hole's gravity snaps it shut. For an advanced civilization, harnessing such an event would be the ultimate exercise in cosmic timing and engineering. They wouldn't need to create the immense energy required for a portal. They would simply need to predict where and when one of these natural events would occur and then be prepared to use it. The first step would be gravitational wave astronomy on an incredible scale. They would need a network of sensors across their solar system, or even their galaxy, to triangulate the source of a merger with perfect accuracy, predicting its final moments with flawless precision. The next challenge would be survivability. Sending a physical vessel anywhere near the merger would be suicidal. The radiation and gravitational shear would tear any known material to subatomic shreds. Their solution would likely be one of incredible subtlety. Instead of a ship, they might send a swarm of unimaginably robust nanoscale probes, perhaps built from metastable neutronium or controlled by quantum fields that allow them to phase through ordinary matter. These probes would be designed to ride the gravitational waves themselves, surfing the ripples of space-time right into the eye of the storm at the exact moment of collision. As the temporary rupture forms, the probes would be injected through it, their passage lasting only a fraction of a microsecond before the gateway collapses behind them. The data they would send back, if they could send any at all, would be the first direct information from the other side, a message etched into space-time itself, describing the laws of a universe born from a different set of quantum choices. This theory suggests that the first travelers might not have been bold explorers, but the most patient and precise astronomers, waiting millennia for the perfect cosmic explosion to send their microscopic envoys on a one-way trip into the unknown. Imagine a universe not made of solid matter, but of invisible, shimmering fields of energy woven into the very fabric of space itself. This is the reality described by quantum field theory, our most accurate description of the subatomic world. In this view, particles like electrons and quarks are not tiny balls, but merely excited states or ripples in their respective underlying quantum fields. The universe is an ocean of these fields, and what we perceive as empty space, the vacuum, is not empty at all. It is a seething, bubbling cauldron of activity, filled with virtual particles constantly flashing in and out of existence, a phenomenon known as vacuum fluctuation. This baseline energy of empty space, the vacuum energy, is the very ground state of reality. Now consider the radical possibility that the specific laws of physics in our universe, the strength of gravity, the mass of an electron, the charge of a proton, are not absolute universal constants. Instead, they might be local and contingent, determined by the specific, stable state that our region of these quantum fields settled into after the Big Bang. This is the concept of the false vacuum. Our universe's physics might be just one possible stable configuration, one valley in a vast cosmic landscape of potential physical laws. Other valleys, other stable states, would correspond to other universes with entirely different rules. This leads us to a theory of breathtaking ambition, that the first journey between universes was achieved not by traveling through space, but by using advanced technology to locally rewrite the underlying quantum fields, creating a bubble of an alternative physics that inherently connects to a parallel reality. The mechanism wouldn't be a portal in the traditional sense, but a region of space where the very rules of the game have been deliberately and precisely altered. To achieve this, a civilization would need to learn how to manipulate vacuum energy directly. They wouldn't be building an engine, they would be constructing a reality editor, a device capable of injecting an immense amount of concentrated energy into the quantum fields at a specific point to push them out of their current stable state and into a new one. The technological implementation of this is almost beyond imagining. It would require a device of astronomical power, perhaps one that could harness the rotational energy of a spinning black hole or focus the entire output of a quasar. This colossal energy would be used to create a focused resonance, a specific vibration in the quantum fields that matches the frequency of a target universe's vacuum state. The process would be one of sublime precision, not brute force. By carefully tuning this energy injection, they could coax a small region of space to undergo a controlled phase transition, like convincing a small volume of water to become ice while the surrounding ocean remains liquid. Within this bubble, the constants of nature would shift. The speed of light might be different, the strength of nuclear forces altered. This bubble wouldn't just have different physics. According to the theory, it would literally be a piece of another universe, its fields now aligned with those of the target reality. For a traveler, the experience would be profoundly strange. There would be no tunnel or window. They would simply pilot their vessel into the designated region of space. As they crossed the boundary, the transition would be felt not as a movement, but as a fundamental transformation of their local environment. Their instruments would go haywire as the laws they were built to measure suddenly change. The light from the stars might shift to an impossible color as the fine structure constant alters. Their own atoms would momentarily destabilize before restabilizing under the new physical regime. They wouldn't be traveling to another universe. They would be bringing a piece of that other universe into existence around them, a bubble of alien physics that moves with them. The first successful experiment might have been a tiny, contained bubble where gravity was repulsive for a nanosecond, or where matter and antimatter did not annihilate. The first travelers would be ultimate reality programmers, having learned that to explore new worlds, you don't need a faster ship. You need to rewrite the source code of your own. But to truly grasp the fabric of reality, we must journey to the very limits of the small, to a scale so tiny it defies visualization. This brings us to the realm of Planck scale engineering, a theory that proposes the ultimate key to the multiverse isn't found in vast cosmic events, but in the infinitesimal vibrations of spacetime itself. The Planck scale represents nature's absolute limits, the universe's ultimate pixel size. The Planck length, for instance, is about 1.6 times 10 to the negative 35 meters, so small that if you enlarged an atom to the size of the observable universe, a Planck length would be roughly the height of an average tree. At this scale, the smooth, continuous spacetime described by Einstein's general relativity is believed to break down into a seething, chaotic foam, a bubbling pot of virtual particles and wormholes flickering in and out of existence in a constant quantum dance. This isn't just theoretical musing, it's where our two most successful theories, quantum mechanics and general relativity, both fail, screaming for a new theory of quantum gravity to take over. Working at this scale wouldn't be like normal engineering. It would be the ultimate form of programming where you're not manipulating matter and energy, but the very bits of information that constitute spacetime. The technological challenge is, of course, beyond monumental. To probe the Planck length directly, you would need a particle accelerator the size of our galaxy, because the energy required to resolve such tiny distances is so immense it would naturally collapse into a black hole. So how could any civilization possibly hope to engineer at this level? The answer might not involve brute force, but supreme subtlety. They might use quantum entanglement itself as their tool, creating complex networks of entangled particles whose correlated states are sensitive to the foam-like structure of spacetime beneath them. Or they might harness the natural, high-energy processes of the universe, like the evaporation of primordial black holes, which naturally emit radiation at energies close to the Planck scale, providing a window into this fundamental realm. The profound connection to parallel universes lies in the geometry of this quantum foam. Some models of quantum gravity suggest that the fleeting wormholes and tunnels bubbling in the Planck foam don't just connect different points in our universe, they connect to every possible point in every possible universe. In this view, the multiverse is not a collection of distant, separate realms, but an impossibly complex network of connections existing at this foundational level all the time. Our reality is simply the stable, classical path that has decohered from this infinite quantum potential. A civilization that mastered Planck-scale engineering wouldn't be creating new connections. They would be finding the stable paths through this natural, pre-existing labyrinth and learning how to stabilize them for macroscopic travel. This would be the ultimate expression of the maxim, as above, so below. To journey across the cosmos, you must first learn to navigate its smallest, most fundamental building blocks. The first travelers would be those who learn to read the universe's source code, not with a computer, but by becoming one with the quantum grain of reality itself. What if the doorway to another reality doesn't require a machine at all, but is instead unlocked when multiple minds achieve perfect harmony? This brings us to a theory that pushes beyond the individual into the profound power of the collective, suggesting that the first journey between universes might have been a shared, conscious experience. Theory 28 explores the captivating idea of consciousness network resonance, proposing that by linking multiple minds together in a synchronized state, a group could generate a resonance powerful enough to temporarily soften the barriers between worlds. This concept draws from ancient spiritual traditions of collective prayer and meditation, modern psychological studies on group intuition, and the most cutting-edge speculations at the intersection of quantum mechanics and neuroscience. The foundation of this idea rests on the hypothesis that consciousness itself is not a passive byproduct of the brain but an active participant in shaping reality, a notion we've touched on with other theories. But here, the focus shifts from the individual observer to the collective one. The core principle is one of resonance and amplification. A single tuning fork, when struck, produces a quiet tone. But place it near another identical tuning fork, and the second will begin to vibrate and sing in sympathy, amplifying the sound. Could consciousness work the same way? If one mind focusing on a specific intention can create a tiny, localized effect on the quantum field, perhaps through the mechanism of conscious collapse, then 1,000 or 1,000,000 minds focusing on the same intention in perfect sync could amplify that effect to a macroscopic, universe-altering scale. The technological implementation of this wouldn't involve building a traditional engine, but rather creating a network for perfect cognitive synchronization. An advanced civilization might develop a global or even system-wide consciousness-linking interface. This wouldn't be a device to read thoughts, but to harmonize them. Participants would enter a deep, meditative state, perhaps aided by technology that gently guides brainwaves into a uniform, coherent pattern, a massive, biological version of the laser we discussed for neutrinos, where countless individual photons are made to march in lockstep. The system would act as a conductor for an orchestra of minds, ensuring that every participant is not just thinking of the same destination, but is feeling and intending it with the same emotional and cognitive resonance, their brainwaves pulsing in perfect unison. The target for this collective intention would be the quantum vacuum itself, the seething sea of potentiality that underlies our reality. The synchronized network wouldn't be trying to push or tear the fabric of space-time. Instead, it would be emitting a powerful, coherent signal of possibility, a resonant frequency that matches the quantum signature of a desired parallel universe. In the many worlds interpretation, every possible universe already exists. The goal of the consciousness network would be to create a quantum standing wave, a zone of stability where the probability of one's local reality overlapping with that target universe becomes not just possible, but inevitable. It would be a gentle act of persuasion on a cosmic scale, convincing reality to reveal a version of itself that was always there, just out of phase. The experience of travel via this method would be deeply communal and utterly transformative. There would be no physical vessel. The participants, who could be scattered across a planet or linked via a quantum communication network, would simply achieve synchronization. As their collective focus peaks, the environment around each of them would begin to shift. They wouldn't be transported. Their shared local reality would itself transform, seamlessly transitioning into the target universe. A group meditating in a forest on Earth might open their eyes to find the trees are now a different, alien species. The sky holds twin moons, and their shared memory confirms they have always been in this new world together. The first successful journey would be the ultimate testament to the power of unified consciousness, proving that the greatest explorations require not a mighty engine but a connected humanity. But if we consider information as the most fundamental currency of reality, a new possibility emerges, one where the past itself holds the key to crossing into other worlds. This brings us to a theory that is as subtle as it is profound, suggesting that the universe might not forget, and that these lingering memories could be the first threads connecting parallel realities. Theory 29 delves into the enigmatic world of quantum memory, a concept where physical systems don't just react to their immediate environment, but retain a ghostly impression of where they've been and what they've interacted with, even across the boundaries of reality. In our everyday experience, we think of memory as a neurological or computational process, but in the quantum realm, memory can be a fundamental physical property. This isn't about a particle remembering a fact. It's about a system's future behavior being subtly influenced by its past perturbations, even after the initial disturbance has seemingly vanished. This phenomenon, often studied in the context of non-Markovian dynamics, shows that quantum systems can have a kind of history, where information about past interactions is not lost but is temporarily stored and can later re-influence the system. It's as if the quantum world has a faint, persistent echo. Now, project this idea onto the canvas of the multiverse. According to the many worlds interpretation, every quantum decision spawns a new universe, but these newborn realities don't necessarily sever all connection. They share a common origin, a shared past. The theory of quantum memory transmission proposes that this shared history creates a fragile, residual link, a kind of quantum entanglement, not just between particles, but between the entire timelines of parallel worlds. Information doesn't travel through space to get from universe A to universe B. It persists because the two universes were never fully separate to begin with. The information was always there, a shared memory encoded in the very fabric of their co-creation, just waiting to be accessed. The technological challenge, then, is not about creating a transmitter, but about building the ultimate quantum archaeologist's tool, a device capable of reading this faint universal memory. An advanced civilization would first need to identify a suitable memory storage medium. The most likely candidate is the quantum vacuum itself, the seething energy of empty space that permeates everything. This vacuum isn't truly empty, it's a dynamic plasma of virtual particles and fields. A traumatic event, like the branching of a new universe, could leave a specific, imprinted pattern in this vacuum, a quantum memory that faintly encodes the properties of the sister universe. To detect this, they might use a device called a quantum memory resonator. This wouldn't be a giant telescope looking for light, but an incredibly sensitive instrument designed to measure the subtle, persistent correlations in the vacuum fluctuations. It would look for tiny deviations from randomness, for patterns in the noise that shouldn't be there, signatures that the vacuum in their local region is still weakly correlated with the vacuum of another reality. It would be like listening to the static between radio stations and slowly, painstakingly, teasing out a faint, coherent signal, a whisper from a world that chose differently. Once they learn to read this memory, the next step is learning to write to it, to send a message or eventually a traveler. They would need to artificially create a powerful new quantum memory in the vacuum, a deliberate and robust imprint that describes the information they wish to send. This could be achieved by performing a massively correlated quantum measurement, an event so definitive and impactful that it forces a strong memory into the shared fabric of reality. The technology for this might be a planetary-scale array of quantum computers, all performing the same calculation in perfect sync, their collective observational act etching a new day to point into the multiversal timeline. A being receiving this message in a parallel universe wouldn't detect a signal traveling through space. Instead, they might observe a sudden, inexplicable anomaly in their own local quantum experiments, a particle that behaves in a statistically impossible way, or a piece of data that appears perfectly formed in the middle of random noise. For them, the information wouldn't arrive from somewhere else. It would simply manifest as a new part of their reality's history, a memory that had, until that moment, lain dormant. The first communication would feel less like receiving a letter and more like suddenly remembering something that never happened to you, a collective déjà vu that contains a perfect, verifiable message from another version of existence. This theory suggests that the first contact between universes was not an act of transmission, but an act of shared remembrance, a poignant reconnection between worlds that had forgotten they were once whole. This brings us to our 30th and final theory, one that places the entire concept of multiverse travel within a grand, cosmic narrative of growth and destiny. The idea of natural multiverse evolution proposes that the journey between realities is not a fantastical exception, but a natural, perhaps even inevitable, evolutionary step for any civilization that survives long enough to master its own universe. This perspective reframes our entire discussion, suggesting that universe hopping is not the final frontier, but the next logical phase in a billion-year story of development. To grasp this, we can look to scales of civilizational advancement like the Kardashev scale, which categorizes civilizations based on their energy mastery. A Type 1 civilization harnesses all the energy of its home planet. A Type 2 commands the total output of its star, perhaps by building a Dyson sphere. A Type 3 civilization achieves mastery over its entire galaxy, wielding energy on a truly unimaginable scale. But what comes next for a civilization that has reached the pinnacle of its own universe, having explored every star, solved every fundamental mystery of physics, and perhaps even achieved a form of collective consciousness or digital existence? The only frontier left is the one beyond their own spacetime. The drive to explore, to ensure survival against cosmic threats like heat, death, and to satisfy an infinite curiosity would inevitably push them toward the multiverse. This isn't a choice, it is the natural trajectory of any intelligent life that refuses to accept boundaries. This push would likely force a convergence of biological and technological evolution unlike anything we can imagine. A civilization at this stage might have long since transcended its original biological form. They could be post-biological entities existing as patterns of information or highly adaptable synthetic consciousnesses housed in robust, self-repairing vessels. Their very nature would evolve to meet the demands of multiverse travel. They wouldn't need to build ships to survive the journey, they would become the ship. Their minds would be engineered for navigating incomprehensible higher-dimensional geometries, and their perception would be augmented to directly sense the quantum fields and gravitational nuances that define the boundaries between worlds. In this view, the technology for travel isn't something they invent separately. It becomes an integral part of their evolutionary development, a new organ or capability that emerges from their complete synthesis with the tools they have created. The method of travel itself might then become as natural to them as breathing is to us. Just as a bird doesn't calculate complex physics to fly but simply flies, a multiverse-hopping civilization might navigate the brains and bulk of existence through instinct and intuition honed over eons. They might perceive adjacent realities not as distant, separate places, but as nearby neighborhoods in a vast cosmic metropolis, and their method of travel could be a refined, effortless version of the theories we've explored. A conscious choice to decohere from one reality and recohere in another, a gentle slide along a cosmic string, or a resonant alignment with the rhythm of a target universe. The first journey wouldn't be a single historic event for them, but a collective evolutionary leap, a species-wide awakening to their true potential and their true home. Not a single universe, but the infinite multiverse itself. This theory offers a profoundly hopeful vision, suggesting that the mysteries of existence are not walls meant to confine us, but doors waiting for us to grow tall enough to reach the handle. From the delicate quantum tunneling of a single particle to the cataclysmic manipulation of the vacuum itself, our journey through these 30 theories reveals a stunning truth. The human drive to explore is boundless, reaching beyond the stars and into the very fabric of existence. We've stood at the edge of black holes, considering them not as endings but as potential doorways. We've imagined civilizations so advanced they could tune reality like a radio, syncing with the rhythm of a parallel cosmos. We've even pondered if the key to it all has been within us all along, hidden in the quantum whispers of our own consciousness. Each theory, from the cosmic strings woven in the universe's infancy to the possibility of a simulated multiverse, isn't just a wild guess. It's a legitimate extension of our most robust scientific ideas, pushing at the very limits of physics, philosophy, and imagination. What makes this entire exploration so profoundly compelling is how it fundamentally stretches our conception of reality. We are forced to ask not just how we might travel to another universe, but what reality even is. Is it a solid, objective stage or a fluid, participatory construct? Are we passive inhabitants of a single cosmic story, or could we, one day, become active authors choosing our narrative from an infinite library of possibilities? These questions dissolve the boundary between science and philosophy, inviting us to think bigger than we ever have before. They challenge our place in the cosmos, suggesting that our home isn't just a pale blue dot, but one thread in an impossibly vast and magnificent tapestry. Now we turn this conversation over to you. Which of these theories resonated the most? Did the engineering marvel of a stabilized cosmic string capture your imagination? Or did the intimate idea of consciousness-led reality shifting feel more profound? Perhaps you have a compelling theory of your own that we didn't cover. Share your thoughts and favorites in the comments below. We are genuinely excited to continue this discussion with you and hear which possibilities spark your curiosity about the nature of everything. As we conclude, remember that the most thrilling aspect of this entire mystery is that the truth, waiting to be discovered in some future experiment or moment of brilliant insight, will almost certainly be stranger, more elegant, and more wonderful than any of our current speculations. The quest to understand the multiverse is far from over. In many ways, it has just begun. So keep questioning, keep wondering, and stay curious. The greatest journeys into the unknown are always